Hi everyone, welcome to this session. So today we will be solving this very interesting interview question. Okay, basically this is a very small circuit, but this is very tricky to solve. Okay, basically we have to find the what will be the output at this, like the op amp output. Okay, and how our op amp is ideal, so the gain will be infinite. Okay, so now to solve this type of circuit, what we need? So you have to check is there any negative feedback or not. Okay, so if we have a negative feedback, we can directly use the virtual short concept. Okay, so for virtual short concept, we know the inverting non-inverting terminal potential of the op amp is exactly equal to the inverting amplifier, like the potential at inverting amplifier of the op amp. Okay, but we have to check the negative feedback first, right? So this is the condition. You can say that if this is negative sign and this is positive sign, so you directly assume this is a negative feedback circuit, but this is not the case. Okay, to find the to check the feedback, what we do? We find loop gain. Okay, loop gain. So for loop gain, what we do? We cut a point on the loop and we traverse the loop and get back to the node again and see is there any 180-degree phase shift or not. Okay, this is the way to find the loop gain, and then we have to deactivate all the independent sources. Okay, deactivate all the independent sources. Okay, so actually we are not going to find the loop gain here. Okay, so loop gain means you can cut this note here. Okay, and apply a test voltage small signal Vt, and you traverse the loop and get back to this node again. Let's say the potential at this node will be V test. Then you have to take the ratio of V test over Vt, and if there is a negative sign, so this will be our negative feedback circuit. Okay, negative feedback means if you increase this potential at this node, at any node. Okay, and you traverse the loop and you get these voltages eventually decreasing, that means a negative feedback circuit. Okay, so actually we are not going to do that. We can directly see that if we redraw the circuit. So this will be 1k, this is also 1k, and this is also 1k, and this current source is independent, right? So the current source will be open circuited. Okay, to find the loop gain or to check the feedback of this, like the which type of feedback in this circuit. Okay, so actually we can see that there is actually no feedback present here, right? Because like no part of the outputs is fed back to the input of this any of these terminals, right? Because this is open and there is no connection. So and we can see that there is no connection as well from output. Okay, so basically in this circuit there is no feedback present. So what will be the circuit here? So basically this circuit acts as a comparator. Okay, comparator. So what will be the output? We know that for comparator, if V positive terminal is greater than V negative terminal, then we get the positive output, positive VDD. Okay, and if we have negative terminal potential, okay, so this will be this. Okay, so negative terminal potential is greater than the positive terminal potential, so this will be minus VDD. Okay, and we have like here given that the op amp runs at plus 5 voltage. Okay, so here plus VDD is nothing but 5 volt, and for minus VDD we can assume this is 0 volt. Okay, so now we have to check what is the positive and negative terminal voltages. Okay, so let's redraw the circuit again. So this will be okay. This is 1k, this is also 1k, this is also 1k, and this is a 1 milliamps current source. Okay, so so here no current can go through it, right? So this zero potential will appear here. So this node potential is 0 volt, right? Because the op amp terminal, no current can go to the op amp terminal. We all know that because this is ideal op amp and this input impedance of this each node is infinite. Okay, so this 0 volt appears here. So the positive terminal potential here is 0 voltage. Okay, so this is ground, so this is 1k and this is 1k. Okay, so we can see that, and this, like no current can go through this terminal as well, right? So we can see that this on milliamp current has to flows through this path, right? So if 1 milliamp current flows through this 1k resistance. So what will be the voltage drop across it? So the current direction is like this, right? So this will be plus and this will be minus for this 1k. And if we multiply 1k into 1 milliamps, this will be nothing but 1 volt, right? So here is 1 volt drop, right? Again, for this resistance, the current is flowing through this way. So this will be 1 volt as well. Okay. So the 1k, like the voltage drop of this 1k resistance will be same as 1 volt. Okay. So now if we redraw the circuit clearly, so this will be plus minus 1 volt and this will be plus minus, okay, plus and minus 1 volt. So this is 1k, this is 1k, and this is ground. So and this is, we have seen that, so this is the resistance of 1k and this is v plus. So v plus is nothing but 0 volt. So in this case, so this will be like this, right? So this is 1 milliamp. So we can see that this potential is grounded, right? So this is zero potential, and this voltage drop across this 1k ohm resistance is plus minus 1 volt. Like the polarity will be plus here and negative here. So if this is 0 volt, this potential must be negative 1, right? So that the potential drop across this 1 kilo ohm resistance with this polarity will be maintained, right? So this is the minus 1. This must be minus 1, right? Because this is grounded. Okay. So now we have find that the V negative will be minus 1 volt, right? So which is greater? So we can directly see that 0 volt is greater than minus 1 volt, right? So here our the non-inverting terminal potential is greater than inverting terminal. So what will be the output? We know that this is a comparator, so output will be plus VDD. So here plus VDD is nothing but plus 5 volt. Okay, so this is the answer. Actually, confusion occurs, like we directly assume that this is a negative feedback circuit. Okay, but actually this is wrong. Okay, this is the correct way to analyze this circuit. Okay, this type of circuit. Okay, basically we have to find the there is positive feedback or not. Okay, and we have to apply the virtual short concept. But here we have seen that there is actually no feedback present here. Basically it acts as a comparator. Okay, so now we have just need to the potential of this V plus and this V minus. Then we have to compare that, and then accordingly we will get plus VDD or minus VDD. Okay, so this is a very simple but interesting question. Okay, so please give your valuable feedbacks. Okay, thank you.